Okay, we're in Solver. We've got the objective cell set here at I12. We've got the variable cells, the yellow cells in here, G8 to G9. Now we have to set our constraints. So you go to add, it says subject to the constraints, and we're going to go add. And I'm going to go one by one. You can highlight a bunch of these at one time. We'll do that on another example just to make it easier. We're going to go this cell, which is B15, and then my symbol here, oops, no, it's this one. Sorry, I don't know why I put that. C15, and then we're going to make sure this is set correctly, greater than or equal to. That's why I put this cell, I put this here and set it up this way so it's real easy to put into Solver. And the constraint here is 15,000.
Good. How'd you get it all in there like that? That's a really big question.
Yeah, I can't help you with that. You can, I'll do another one. And so once it's in there, if you have more to do, just click Add. And we'll go to the next one. C16, greater than or equal to E16. You can type these as well if you like to. Then we're going to go Add, C17, and this time we don't change the cell.
Do you put semicolons in between?
I'm only using my cursor. I'm not typing anything right now. I can come and help you in a minute. Let me work through this and then I'll come help you. C17, less than or equal to E17. Click on it again. One more, add. C18, less than or equal to E18. And then you click OK. Now, if you can click OK in the middle of all that, it'll take you back here, and then you just hit Add again. It's not a big deal. We want to make sure that this box is checked that says Make Unconstrained Variables Non-Negative. Okay, somebody asked me day one, I remember something about non-negative or something, so that's how Solver does that. We want it to be simplex. We want LP, which is linear programming. This is a linear programming model, so we want it to be linear, because what we've just done is a whole bunch of linear algebra, but you didn't know it, because we did it in Excel, and most people's brains work like Excel. Most people's brains don't work like linear algebra problems. So that's why Excel is so popular. So you click on Simplex LP, and then we will hit Solve. And if everything happened correctly, it will say Solver found a solution. All constraints and optimality conditions are satisfied. And then it'll give you the option, keep Solver solution or restore original values. I always click OK. And you should have this answer. So it did it for you, 625 and 1,000 shares. And your profit will be $27,375. Solver, this is about as basic as you ever get with Solver. You could already see the power of it. Yes?
I have everything except for what you put in the right cell for profit. That's a question on realizing potential. Like, where we subtract the amount of the non-investment out of invest on to take over.
Yeah, I'll just click on it and you could see I10 minus H10 on my sheet.
Yeah, I just wanted to make sure.
Yeah.
In Solver, I added all the constraints. What was the last step?
Make sure you're setting it to linear,
Okay.
and then click Solve. If it's not linear, you won't always get the same answer. So if I can help you, I can go back into Solver. Oh, I gotta get out of that cell. If I go into Solver, you see right here it says Select a Solving Method. Make sure it's Simplex LP.
Yeah.
Now, some of you, if you may have a different version and you have to go into the options to set it to linear, that happens too.
I hit solve and it says objective cell contents must be a formula.
It's
So that-
you're missing one.
You're not, you have to have a formula in the red cell.
I must page 10 minus.
No, I'm finished.
Are all of them we're gonna do gonna be that simplex LEDs
Yes.
for the entire class?
For now, yes. There are times later where we get really complicated that you can set it to nonlinear and it will work, but that just means that your model, if, I don't want to scare anybody off by saying this, but if you, some of these problems, you can include if statements in your formula. You don't need them, but it's a shortcut. And if you use if statements are not linear, so you have to change that to nonlinear and it'll then work. It's kind of a shortcut. I use when I'm in the workplace, I use that all the time because the model can be simpler, but you don't ever need to do that. So you can leave that the whole semester and be fine.
And would we always make our variables non-negative, or would that only be like in the case of?
Sometimes if you set the thing up in a very odd way, you can unselect that and it'll work, but by and large you want to have that selected. I don't think it would matter in this one. I could be wrong. I'll unselect it and see what happens. Yeah, it still works without it on this one because we have two minimums and we're maximizing. But if you're minimizing something and you don't have minimums, it'll go below 0.
Yeah.
So is this saying that initially we bought 625 shares of Eastern at $40, and
Yeah.
then when it got taken over, they paid us $55 a share for those?
Yes.
Okay.
So we made, the profit we made for the takeover was $34,375 minus $25,000.
Okay.
That's the profit for Eastern.
Because I was thinking, never mind.
You're trying to outsmart the computer?
I was thinking, since we're getting $55 a share, why don't we just invest $40,000 in Eastern? Because obviously we have to invest $10,000 in CommSwitch, but I understand that.
Why not invest? Why didn't it put 40,000 here?
Yeah, because then that's the highest price per share, but I wasn't, it's fine, I understand.
Well, there's more profit here.
That's what I wasn't,
Yeah, okay. So the thing that messes us up, in terms, if we're digging a little deeper, is this, if they didn't have this cap here, everything would go in
Yeah.
there. Yeah. How are you guys doing over there?
Well, I know how to do the formula, I know how to solve it, but my numbers are off.
Okay, I'll come look in a second. That means there's some little error in there and we'll find it. Okay,